Radios here. In this video, we'll create a React LineChart component without relying on external charts and libraries. This task may seem daunting at first, but you'll find that it becomes manageable and straightforward when we break the component into smaller, more digestible parts. This modular approach not only simplifies understanding, but also makes it easier to adapt and extend the component for your specific requirements. The demo and source code are available in the RadzionKit GitHub repository. You can find all the resources mentioned in this video in the description. First, let's examine our line chart and deconstruct it into its core components. The central element is the line chart, notable for its curved line with a gradient fill. Next, we consider the x-axis labels. Given its potential utility in other charts such as point or area charts, we have amply named this component ChartXAxis. Following this is the LineChartPositionTracker, crucial for the hover effect that highlights a specific point on the line chart. This component is uniquely important for its dual functionality. It not only emphasizes the point, but also includes a callback property to identify a selected data point. Such a feature is vital for LineChartItemInfo, the final component in our lineup. LineChartItemInfo is responsible for displaying information about the selected point positioned above the chart. With these essential components identified, we are now ready to start building our line chart. Every top-level component of our chart must be aware of its container's width to accurately calculate the positions of various elements. Therefore, it's efficient to obtain the container width at the top level and then propagate this information down to the component that requires it. To accomplish this, we can utilize the element size aware component. The useElementSize hook is specifically created to monitor the dimensions of a given element, specifically its width and height. This hook updates these dimensions whenever there is a change in the element. To achieve this, it employs the ResizeObserver API in conjunction with the useIsomorphicLayoutEffect hook. The useIsomorphicLayoutEffect hook serves the same purpose as the useLayoutEffect, but it does not generate errors during server-side rendering. We will use a flexbox element with a 4 pixels gap as a container for our chart components. By assigning the setElement function to this container, we initiate the monitoring of changes in the container's dimensions. This is crucial for rendering the chart components accurately when their size is determined. The first component to render is the LineChartItemInfo. This component plays a vital role in presenting information about the selected point on the chart, such as price and date. To manage the state of the selected point, we employ two variables, selectedPoint and isSelectedPointVisible. This approach serves two purposes. Firstly, it ensures that LineChartItemInfo is always rendered even when not visible to prevent abrupt appearance on the screen. Secondly, it facilitates a smooth fade-out animation when the information becomes invisible, achievable through CSS only if the element is constantly rendered. Within the LineChartItemInfo component, we have the flexibility to include various child elements. For our specific use case, we will employ a vStack component to vertically stack two text components. The first text component is dedicated to displaying the price of the selected point, and the second text component is tasked with showing the date. The LineChartItemInfo component is strategically designed to position these elements above the chart, ensuring alignment with the selected point. Before delving into the implementation details, it's important to discuss the final property data. In our chart components, data is represented as an array of numbers, specifically ranging from 0 to 1. To accomplish this, we utilize the normalize function. This function identifies the maximum and minimum values in the array, then maps each value to a corresponding number between 0 and 1. For our Bitcoin price chart, the focus is solely on the price values, as these charts typically feature a linear x-axis marked by uniform intervals, and we can always derive the corresponding date from the index of the value in the array. Working with normalized data allows us to implement an interesting technique to introducing vertical pattern to the chart. This is achieved by appending two extra values to our data array, one greater than 1 and another less than 0. This manipulation causes the rest of the chart to appear smaller, effectively creating a padding effect. Examining the implementation of the LineChartItemInfo component, we start with its top container, a standard div element with a width set to 100%. Interestingly, there is no need for absolute positioning here. Even the margin left property suffices for positioning the info. To calculate margin left, we require two pieces of information: the width of the container received from props and the width of the content determined by the element size aware component. Initially, while the size is being calculated, we set the component visibility to hidden to avoid any abrupt appearance on the screen. Once we have the size, we can accurately calculate the margin left. This calculation involves the index of the selected point, the container's width, and the content half-width variable, which helps us find the content center. The logic is straightforward. If the container center is less than the content half-width, margin left is set to 0. If it's greater than the container width minus content half-width, margin left becomes outer. In all other cases, margin left equals the content center minus content half-width. This ensures that the content is always amply centered above the selected point. To achieve a smooth fade-in and fade-out visual effect, we manipulate the opacity property, setting it to 1 when visible and 0 when not. Moving on to the LineChart component, it accepts properties like width, height, color, and data. The chart is rendered using a fixed size SVG, which is composed of two paths. The first path is responsible for rendering the line of the chart, while the second creates a shape filled with a gradient. This setup requires the implementation of two functions: create path and create closed path. These tasks are well suited for ChatGPT's capabilities. Although it won't handle the entire component creation, it can significantly assist with straightforward tasks like this. The gradient applied in the chart is designed to start at 40% opacity and gradually transition to 0%, resulting in an aesthetically pleasing fade-out effect. For color management, my applications utilize the HSLA color format. For those interested in exploring more about this color format, I recommend checking out a specific video about it here. The next component in our lineup is the LineChartPositionTracker. As it's an absolutely positioned element designed to span the entire area of the chart, it must be rendered alongside the line chart within an element that has a position relative. This arrangement ensures that the LineChartPositionTracker is correctly positioned over the chart. The component receives data, color, and an onChange callback as its properties. To accurately track the mouse position over the chart, LineChartPositionTracker incorporates a hover tracker component. This hover tracker is essential for monitoring mouse movements across the entire area of the absolutely positioned container. The hover tracker component is an essential part of our setup with two key properties: render and onChange. The render function is responsible for propagating properties to the target element. This propagation is crucial as it allows hover tracker to listen for mouse events and access the ref, which is necessary to determine the element's bounding box. During a mouse move event, the component captures the X and Y positions of the mouse and compute their relative positions, which are continually normalized in range between 0 and 1 for both coordinates. To keep the parent component updated about these positions, hover tracker utilizes the use isomorphic layout effect hook, the same one we have encountered previously. With the mouse position known, we can render the LineChart position component. This component is responsible for displaying two visual elements on the chart: a vertical dashed line and a circle to highlight a point. When dealing with absolutely positioned elements, it's quite often we know the center of the element, but there is no direct CSS property to position element by its center. Therefore, we usually calculate the left and top property by taking the central coordinates and subtracting half of the element's width and height respectively. To simplify this process and avoid duplicating logic across different components, we can utilize helper components like position absolutely center vertically and position absolutely by center. This component streamlines the process of positioning elements based on their center, making it more efficient and reducing code redundancy. Position a dashed line, we utilize the position absolutely center vertically component. This component allows us to define the line's left position by converting the X value into percentages. We set the full height property to true, ensuring that the line extends across the entire chart's height. The position absolutely center vertically component creates an absolutely positioned wrapper with the top property at 0 and the left property at the specified value. Inside this wrapper, we place a flexbox element with relative positioning and justify content center to align the line vertically in the center. Finally, the content component is rendered with an absolute position, and thanks to Flexbox justify content property, it is centered vertically. For positioning the point, the position absolutely by center component is employed, adhering to a pattern similar to the previously mentioned component. This approach encompasses a relative wrapper paired with an absolutely positioned container, the latter being a flexbox with its alignment centered. Within this framework, the content component is also positioned absolutely. Such an arrangement guarantees both precise and centered alignment of elements. Finally, for displaying the x-axis labels, various methods exist for label placement and selection. While the simplest approach would be to distribute the labels evenly across the range using absolute position, we will adopt a different strategy here. Our ChartXAxis component, similar to previous components, accepts data, container read, and render label as props. The key distinction, however, lies in our approach to label sizing. Instead of measuring label sizes, we request to provide expected dimensions for label width, height, and preferred spacing. For positioning the labels, we calculate the pixel distance between points and iterate over the data to create an index array of labels to be displayed. This is determined by ensuring each label starts and ends with at least a label's mean distant pixels from the previous label and the container's end respectively. Subsequently, we utilize the position absolutely centered vertically component as seen earlier to render these labels at the calculated positions. That's all. If you found this line chart breakdown useful, please like and subscribe.